This is the one we're going to focus on. Notice she completes the full rotation, and she's got some decent velocity as she gets to the top too. So turns out in this one, she's actually added some angular momentum from beginning to end. Remember talking about conservation of angular momentum last time, and we went through some examples of, the diver. It was conserved in that case. Was it conserved with the gymnast? No. There's a huge torque. Right? External torque is what makes momentum, angular momentum, be changed. And if we look at this one, partway down, she's got a really long radius here. So there's the perpendicular distance from her center of gravity over to the bar is really big. It's well over 1 meter with full body weight. So there's a huge torque on the way down created by gravity. That's going to add a lot of momentum on the way down, and then on the way up, that torque is going to take away some of her angular momentum as she heads up. So if she kept the same radius all the way through and there was a bit of friction, bit of air resistance, she wouldn't make it all the way around. She would have lost some of that momentum, or she'd have lost equal momentum on the way up compared to on the way down. And the friction and air resistance would have taken away anything else, so she wouldn't make the rotation. We're going to use some digitizing, clicking on the screen to see where the hip is, how the path it follows, and so on throughout the motion to understand how this is possible that she can get the full rotation in. So you have a few steps here. I've got these written up. Steps for digitizing, that's what I'll demonstrate for you today. And then the steps for calculations, I'll just go through in class, and if you need to review them, I'll have the video up later today that you can skip through the video to get to any parts that you might need to review. But take some good notes, especially when I'm showing you the steps for the calculations. You'll do all of this in a spreadsheet, and some are great at spreadsheets, some haven't done much with them before, so make sure you have the notes you need to be able to get through that. The focus of the assignment is to understand angular mechanics with the giant swing. It's not how to use spreadsheets. So if you're struggling with a spreadsheet or any of the digitizing along the way, then come visit with me and James and get some help through that part so you can get to the important thing, which is understanding the motion. All right, so on these, the spreadsheet, I probably recommend getting that first. Just click on this link and it'll look just like this one does. You'll have empty graphs, empty data other than the time column. We're going to do some digitizing to get these columns created, and then you'll enter some formulas to finish off the rest. Right, to do the digitizing, data collection for giant swing, you click in here, and it'll take a little bit of time to load. Pretty quick there, I guess. If you're on Wi-Fi, it'll take a little longer. There's about 180 images built into this of that giant swing. So it takes a little while to get loaded. If you change the screen a little or go off of it and come back, it'll take a few seconds and then appear again. Just like a little mouse movement helped it refresh. I wanted you to see the whole screen. So tells you here what to do. Click on the hip throughout the motion. Whichever column has the dark blue background, that's the column you should be working on. So you start off just by getting to the hip joint center. The goal of choosing the hip is to have it be a good estimate of where the center of mass of the body is. The hip's pretty close to that. And as the hip gets closer to the bar from doing some extension of the shoulders, that gets the center of mass closer to the bar. So it's going to be a decent estimate for us of getting center of mass location. So it takes a while. I'm guessing it'll take you about 2 or 3 minutes to click through all of this. That's just the nature of biomechanics. You often have to spend a lot of time getting the data created correctly. All right, let's go a few more. I'll get it to the 90-degree position. From there, it starts going a lot quicker because it starts moving faster. Okay, so there's part way down. You'll need to finish the hip all the way through before you click anywhere else. Otherwise, you're going to have to start over again. If you mess up, click on the hip button and it'll clear out that data, those data, and you can redigitize the hip. When you finish the hip, and actually I'm just going to kind of randomly click to finish filling in the column to make sure this works the way it should for you. So that was bad digitizing. That will not help you get the questions right if you do it that quickly. But when you get to the end, it says point finished, click OK. Now clicking on the screen does nothing. You need to choose which one. You can click hip if you want to redo it because you thought, oh, I was messed up on some of that. Or if it's good, just leave it and click the grip button. So it says choose the next point or copy the data. For now, we can just choose the next point and fill this one in. The goal of the grip is to click where you think the axis of rotation is, which will be right at the grip until that bar starts bending. But notice the hands are rotating around, so it's still pretty close to the center where the center of rotation would be. And that point's finished. And after you calculated or digitized those, digitizing just means clicking on the screen and getting a coordinate for it, the angle started getting filled in. So from this point, I'm hoping this will work. If not, I have a backup plan to get you through it. You should be able to just click select hip, and then it says copy to clipboard, Control-C or Apple-C if you're on a Mac, and then click OK, and then we paste it in. Yeah, there's still that little glitch there. I thought I'd fix that, but obviously it's not good. So select the numbers per hip. Select and drag, scroll. Make sure you only have the number selected, and then you can go right here and do paste, and that'll paste the numbers all the way through to the bottom where the time of 0.825, that's the end of the digitizing. It'll be double that actually. There's one other little problem. It's actually a 60th of a second in between. I took out half the frames to save you a bit of time on getting these calculated. So the entire swing takes 1.65 seconds. All right, now the next column is the grip. So we go over here and select the grip numbers. Control-C or Apple-C, then go to this cell D2 and paste the grip numbers. And then I'm going to show you something that happens with the angles, and then I'll explain why I have this filter data button. Okay, we paste the angle numbers, and then you've got all of your digitizing and copying and pasting finished. Now if I graph the angle numbers, notice there's this up and down fluctuations going along. It should be a nice smooth curve all the way through. Even initially, it looks like it's not quite as smooth as the movement probably was. That's because when you digitize, here's the path the hip actually followed, but when I click, I'm not always right on that line. That's what we call noise when we're doing this kind of measurement, where it's noisy data, not really showing exactly the true data. It's a little bit off because we're not clicking exactly in the right place. We do something called filtering to take care of that. So after you get the angle column angles calculated in there, before you copy it, click filter data. Watch the numbers in the angles column as I click this, and notice they changed a little bit. When I copy these, being careful again just to get the numbers. Copy over in the spreadsheet, click paste. Watch what happens to the graph that I just created. So it got smoothed out. So it takes some of that noise out and fits a smoother curve throughout. That'll make your graphs in the end look a lot better if you use the filtered data. So here's your steps. Open it up. Be patient. Sometimes it takes a few seconds. And then just start clicking on the hip all the way through. Then when that's finished, click on grip. Click on that all the way through. It'll create the angle numbers. Click filter data. I'll work on trying to get these selection buttons working, but I have my doubts about whether I'll have that sorted out today. So instead of using those, just select the numbers like that, copy them, paste them into cell B2, D2, and then F2. Any questions on getting through that? Yeah.
Did we need to change the number of seconds or whatever you did discuss at the beginning?
I'm going to update that spreadsheet as soon as we finish class. And that column doesn't actually go into any of the calculations, so it won't really matter in the end. But I'll get that corrected myself. Then when you download it, it'll be fixed. If you already download it, I know some of you are working already, then in cell A3, make sure it says 1/60th of a second instead of 1/120th. And then with that cell selected, if you go to the bottom right corner of it and double click, that'll copy that formula all the way down to the bottom, and the last one will say 1.65. But if you wait till after class, I'll have that corrected for you anyway. Yeah.
For digitizing the grip, did you want us to follow the grip or the center of
Where you think the center of rotation would be, which ends up being pretty close to where the grip starts. When the bar is bent, the bar is rotating around that point. So visualize it how you see it, and it's probably closer to the starting center point than following the actual grip. Okay. Any other questions with getting through that part, just getting the data copied into the spreadsheet? In the last class, we had about 10 laptops out working on it. For some reason, 2 of them, it wasn't working well enough. It was really slow to respond. So they'd click on whatever point, and it wasn't refreshing to the next position, things like that. So on most, it was fine. I'm guessing it was either the computer was slow with its network connection. That's my guess of probably the issue. So if you're having trouble with whatever laptop you're using, try it go into a computer lab or somewhere where you have a wired internet connection. Maybe even that same laptop's fine if you move somewhere else and had a better connection going on. So it seems to work on any browser, but I haven't tested it thoroughly all over yet. Yeah.
Can you say what you did to my guy about the cell and A2?
Oh, yeah. After class, I'll have this fixed for when you download it, but it should say 1/60th of a second it'll take the 0 in cell A2 and add a 60th of a second. Once you've corrected that one, you select cell A3 and double click on the bottom right corner, and that'll copy that formula all the way to the bottom. Tablets should work for this, but clicking on the tablet, it's hard to be very precise on where you're clicking. So I'd recommend you do it on an enormous tablet. I don't know how big it would have to be real precise, or just use a computer and a mouse, and you'll probably have better data to create the graphs with if you do that. All right, now if we go back over to our steps, we've finished steps 1 through 10 there. So I'd advise for now, if the select button isn't working, hopefully I'll have that sometime figured out today, but manually selecting will be the way to go to be totally safe. So I'd recommend you just go with that. I should show you one thing that happened there. If you start right on one of the numbers, make just really far to the left. Notice it selected angle, it selected this text, right? Yeah, I guess it selects them both together. So if I go just a little too far over from that 2, then it starts selecting other stuff and the copy paste won't work. So if it's not copying and pasting correctly, make sure you just have the number selected and nothing else. Otherwise it'll give you some troubles when you do paste. Outside of that, it should be fine for working through it. And so we go to our next part. This is formulas from the Angular Motion chapters into the spreadsheet. And then you go and answer your questions on Learning Suite. So the rest of the work will be right in here. We need angular velocity, which we've done that formula before. Angular velocity equals change in angular position over change in time. We need radius, which we'll get from the Pythagorean theorem, and we need angular or linear velocity. So since we're using the SI units, we need the angle in radians, not just degrees. When you have your F column, if you browse through it, it should start a little above 0 and end around 350 something and should be increasing all the way. So there's a good check for you to look through. In the G column, we're going to take those degree numbers and convert them to radians. So we press equals first. Equals makes it so that the spreadsheet knows a calculation is going to occur. And there's one built in for radians. You could do equals pi over 180 times the angle in degrees, or you can just type radians, start a parenthesis, click on cell F2, end the parenthesis, and press enter. That's the built-in function in Excel to calculate from degrees to radians, and it goes to something like 18 decimal places. And then you'll have a radian value in cell G2. For copying that, you can either click the bottom right corner of the cell and then drag down to the bottom, and it'll always look to the cell to the left to do a calculation. A shortcut for that is select the cell, go to the bottom right corner, and double click. And it goes down until it stops finding data off to the left. That's a nice quick way to get that column finished. Okay, so that's the first one. Some people, that's stuff you do all the time with spreadsheets. Some, maybe you've never done that, copying and pasting. So any troubles with column G? Yeah.
I was trying to know when the second shortcut.
Oh, okay. So when you have the equals radians of the cell all done correctly, have the cell selected, drag over the bottom right corner where the cursor changes to the plus you see there, and just double click. And that'll copy it down to the bottom. Okay, any other troubles with the G column? Next, angular velocity in degrees per second. So let me show you one option for doing this that I don't think is as good, and then I'll show you the good approach. This one's simpler to understand, but don't bother copying it down because I'm going to change it. We do the difference in the x or in the positions divided by 1/60th of a second. That gives us a change in position over change in time. So that seems all right, except the angular velocity that got calculated is the average angular velocity between frames 1 and 2. But it's lined up on frame 1. So it's like the data got skewed a little bit, shifted upwards. So an approach that I prefer for this is start in row 3, the second frame of data, and in parentheses we do the difference in the positions, but we go the frame ahead minus the frame behind, and then divide that by 1/30th of a second, 2 times the change in time. So it's still change in position over change in time, but then row 3 gives us the value that represents the average between rows 2 and 1, or 4 and 2, I mean. So the data lines up nicely when we do that one. They call that the first central difference approach for calculating velocity. And then you do the same thing as we did before. You've got the cell selected, double click on the bottom right corner, and that sends it all the way down. But the very last cell, it's going to look at those to do its calculation, which doesn't make any sense. That's going to do 0 minus 338. So the last cell we just delete. And then you've got your angular velocity all the way through. The next column, we need the radian per second value. So you can do that formula again, focused on the G column. Or, since this one looks at the F column, we can copy that one sideways, click and drag that bottom corner to the right, and it'll move the references over to the G column. So now we've got angular velocity in radians per second finished. We select that cell, double click the bottom right, and that sends it down to the bottom. Remove the end one, and then we've got both our angular velocity columns done. Okay, so here's our formula generally, but it's in the wrong column. But if we move that formula over to the right one spot, then it looks at the G column instead. Okay, so it's the same as copying and pasting it downwards. We're just doing it sideways instead. And then double click that bottom right corner and remove the last cell because it's looking at 0 minus a number. And delete that one. Okay. Any other troubles through that point? When you're actually doing this spreadsheet, you might find that you run into some troubles somewhere along the way. So I'll have this video up later today. You can jump through to whichever step you need to get to if you need to see any parts again. But good notes is probably a quick time saver for you too. All right, on our digitizing, we have this idea created. We have a hip or a grip location and a hip location, and this would be the radius that we're interested in. You see any methods we could use to calculate a radius there based on the numbers we have in our spreadsheet? Yeah, down. Okay. Yeah, we have to separate it into the components of X and Y. So it would look something like this. We're going to create a triangle where this is the X of the hip minus the X of the grip, and this side would be the Y of the hip minus Y of the grip. Yeah. And that gives us 2 sides of a right triangle. So for our spreadsheet, it looks a little messy. It's square root of, then you need a second parenthesis, difference in the x's squared plus difference in the y's squared. Take a look at the parentheses in that formula and see if they make sense to you. If you have any parentheses wrong in that, then it's not going to work correctly. The black parentheses are enclosing the entire thing, And since we need to square the differences in x and y and hip, or between hip and grip, we need parentheses around the D2 minus B2 and the E2 minus C2. And then shift 6 is the caret symbol. That represents to the power of. Any troubles there looking at that formula? Okay. Let's copy that one down. Your radius should be somewhere above 1 usually. I don't remember by how much, but pretty close to that. And if we double click that bottom right corner, that copies it down to the bottom there. And we've got our radius column. And notice the graphs are starting to fill themselves in. These look very bad because I was just kind of clicking randomly so I could show you the process. But your graphs are going to have shapes that'll make sense when you start doing the Learning Suite questions. So they won't look exactly like this. They'll have up and down fluctuations, but will be more useful than what I'm showing you. Okay, how can we get the linear velocity column? There's two methods that would work. You see any way we could get linear velocity based on what we have? What's that? I and J, angular velocity and radius. Yeah. So you hopefully at least recognize this formula when I show it to you. Angular velocity times radius equals linear velocity. We go equals column I multiplied by column J, or at least the cells there for that first one. And so that's a nice quick way. The slow way would be a distance formula, Pythagorean theorem between hip and grip on frame 1 to frame 2, subtract those, divide by the time. That would be a very long, messy formula. This way, knowing this and saves us a lot of time. And then we select that cell we just did the calculation on. The chart's in the way it looks like. There we go. Double click the bottom corner, and now we have a linear velocity column. We need to delete the last cell for the same reason we deleted them there. If you want the cells to look a little nicer for digits, you can select them, and there's this decrease decimal button to make it a little more readable. You're not actually turning in the spreadsheet. You're just going to be answering the questions that you have on Learning Suite based on the shapes that you'll see on these graphs. So the graphs should create themselves for you. Zoom out again. So your spreadsheet will look like that in the end. You'll have 3 graphs that you'll be able to use to help you get your calculations done. All right. Any questions through that? Yeah. Yeah, let's make it a little bigger. Okay. Equals I3 asterisk is multiplied by J3. Okay. All right, your questions on this are what is happening to angular inertia throughout the giant swing? How would you know what's going on with angular inertia? Here's our formula. Do we have anything in what we did that would give us a sense of inertia? How it's changing? Yeah, the radius will help, right? We've got K and R and mass. We don't know our mass. We don't know K. We don't really know R. But the distance from hip to grip is pretty close to R. And as she does this extension at the shoulders, she's bringing the mass closer to the center. So digitizing between hip and grip is pretty close to seeing what's going on with that actual radius. Also, as she does that movement of extension of the shoulders and some flexion of the hips, that's decreasing K also. So K and R both decrease together or increase together. And as that happens, we'll see radius graph changing. That tells us what's going on with the inertia. So there's a question about what's happening with inertia. You'd look at your radius graph to understand that. There's one asking about the pattern of angular velocity, how that's changing throughout the swing. There's one that asks about the momentum. We don't have the momentum, but we do have I and omega, so we can at least get a sense of what's happening there with the angular momentum. The angular velocity changes by huge amounts, and the momentum will match that pretty closely. The inertia, you'll notice radius does change by a meaningful amount, but not by as much as the angular velocity is. So you can almost take the shape of angular velocity and just call that the angular momentum. It's going to be really close to it anyway. And then the other question gets at how is this all working? It's a question talking about the concept. And there's a couple reasons this move works. So I want you to be aware of how that problem is working. Let's see, I just want to show you the fourth question. Oops, got to choose the right exam though. This one. Okay, it says choose two responses. And then as I was creating it, it said, do you want to prompt everyone to choose two answers? So you see it twice there. So don't just choose one and think you're finished. They're checkboxes, not options. And it looks like you can choose more. You need to choose exactly two. I'm not sure what happens if you select all of them. But getting them correct, the two that you enter, it's half a point each. So it's a 1 point question still, but you have to choose two responses to get all the points. If you get one of them selected right, but you choose another one that's not right, you get half a point on it. So that's how that problem's working. All right, so your summary is go to this assignment 5, click on Giant Swing. Be patient for it, especially if you're on a slower connection. Digitize the hip, digitize the grip, click Filter Data, then manually for now select the numbers, making sure you're only selecting numbers and not going over too far there. Copy, go over to Excel and paste the hip numbers, then select the grip, select the angle, get all the data pasted in, create these formulas, look at the graphs, answer the questions on Learning Suite. Anything you want to review considering all of that? How to what? Oh, that is from clicking on Assignment 5, Data Collection for Giant Swing. One thing I noticed, maybe I mentioned this already, if you go off the page and come back, sometimes it's not all cached in there, and if I change the size, notice it flickers a bit, waiting to refresh sometimes. It's actually going pretty quickly right now, but sometimes it'll take longer to refresh. You need to wait a few seconds if you come back to the page. But in my experience so far, it always does come back. You might just need to wait just a little bit for it to actually happen. The only problem I'm anticipating with getting the data copied is that idea of selecting not just the numbers. And I'll hopefully fix those select buttons soon, and that'll work for you. But I don't anticipate problems, but if they come up and you're getting frustrated with it not doing what it should, just come get some help on it. Come to my office hours or James and let us help you through it so that you're not just stuck on the technology of it. The point is to understand how the giant swing works with angular motion. So that's where I want your focus to be. So if you're having spreadsheet troubles, one column just isn't doing the formula you thought it should be, then email me the spreadsheet. Let me show you what's wrong, or come by with it on a drive and let me help you through. And then you can focus more on the questions and understanding the concepts that I'm hoping you have. All right. Have some of you been doing this as we go? Have you had troubles that I could address now? Has it been slow or has it been pretty good? No real troubles?
Really slow. I had to just close it out and try it again.
And then it was fine. So refreshing and then it was good? Okay.
The hand grip, it doesn't, the hand grip, or I guess where the center of rotation, it doesn't really move much, right?
Not really.
So what I noticed is that if you keep clicking, unless you actually move the mouse around,
Oh, yeah.
it doesn't refresh. So you just, if it looks like it's just frozen,
Oh.
just move it a little bit and
Yeah.
the person will go.
So when you're on grip and you're just clicking super quickly, you might be clicking before it's finished advancing to the next. And so you might need to just click, 4 times a second instead of as quick as you can. This one, it seems fine, but it's got a good fast connection going, and it's actually a brand new computer. But yeah, if it seems to be delayed, just slow down on your clicking a little, take an extra 20 seconds to finish, and and then it should be good. But yeah, if it's given you huge troubles, just try a different computer, or bring your laptop to a better Wi-Fi zone where you have a little stronger signal and it'll keep up better.
Did you maybe write the equations how you did it on the board, like just like
With the actual spreadsheet versions of it, yeah, that would be good. Okay, so the first one is equals radians of, which cell is it? F2. And then the next one is equals F4 minus F2 divided by 1 over 30. The next one is equals G4 minus G2. And then the radius, this one's a bit longer, equals SQRT, 1 parenthesis, 2 parenthesis, then it'll be D2 minus B2. Caret 2, I'm going to run out of space there, plus E minus C, E2 minus C2 squared, and then end the parenthesis. Then the last one will go in row 3, and it'll equal I3 asterisk J3. And now you might be thinking, why didn't Dr. Hunter just fill in all those formulas for you? We paste it and then we have our graphs. There is a reason. The focus really is how to understand the angular kinetics, but a little bit of spreadsheet work, it's good to learn how to do some of this stuff. You'll find some good uses for practicing using formulas in spreadsheets. So I do want a bit of spreadsheet practice out of requiring you to do this assignment and fill in those. I'm trying to make it as easy as I can, but I want you to actually go through that process, because that will likely help you outside of this class too, just knowing how to use spreadsheets better. Yeah.
Just out of curiosity, like what program are you using when you're doing the hip and wrist?
Like to create that. It's all in JavaScript, but there's this program called Adobe Edge that does a lot of writing the code for you. And then I just copied it onto the web server, and there it is. But Adobe Edge Animate is what I used to get the JavaScript created. And it took a long time. because I'm not all that experienced with it. Ran into a lot of problems, and they're mostly fixed other than a little issue with the selecting still that I'll have to sort out. Okay, I think that's it. I would like you to do the digitizing and copying and pasting today. Have columns B through F finished today. And if you run into problems, let me help you out, or at least you'll have a few days for me to help you. If you wait till the last day to do this and run into some problems with that part, then it might be hard to find a way to get with me or James before it ends up due. So try to do that today while it's fresh in your mind. If you have a problem, we can hopefully get it fixed by tomorrow, and then you can just be getting the calculations done and answering your questions. So get an early start. There's only one more assignment like this, and that goes pretty quickly. This one will take a bit of extra time, so get an early start and let us help you through troubles that you may run into along the way, or maybe you'll be fine and you'll just be done early, and that's a good thing too. So that should do it. Okay, I'll see you Wednesday. We're going to start with a quiz on Chapter 9, the angular kinetics.